So we know some things about divergence already, right? We know, okay, it's the del operator dotted with vector field. Okay, great. And in the last video, we saw calculations and kind of started to connect it to the geometry, but we still have this kind of vague idea of geometry. And so here's really how we interpret divergence geometrically. Okay, so we have a vector field. Okay, great. We're thinking of it for right now as the velocity of a fluid. And there's maybe other contexts that you can apply this to, but we're going to think about the flow of a fluid. Then with this interpretation, the divergence at a particular point in that vector field really measures what we think of as infinitesimal flow. Infinitesimal flow. Okay, and what we do, how we think of this, is really we think of as kind of the net flow net flow out, and then minus net flow in. Okay, so flow out minus flow in. Okay, and that's why I was, when I was using my language before with those examples, I was really looking at, okay, well, how much is going out, how much is going in, and kind of comparing those two. Okay, so maybe revisit those examples now with that enhanced understanding, and maybe you can better argue as far as why it's positive or negative. Okay, and so really when we say the divergence is positive, we're saying that the flow out is greater, and conversely, when we say the divergence is negative, we think of flow in as greater. Okay, and really what we're doing is we're talking about the entire vector field, right? But we're focusing on a small region just to kind of see, okay, well, within this small region, are we flowing out faster than we're flowing in? Okay, so something, and that will hopefully represent the entire region. Okay, and so here, if we kind of look at the algebra, and maybe that'll help inform us of the geometry. When we look at the gradient, or not the gradient, the divergence here, remember this is going to be mx plus ny plus pz. Okay, and so when we look at mx, that really is measuring the growth or expansion of the x component in the positive x direction. Okay, so if we look at kind of this idea, okay, so we're looking at a small region within our vector field, and in this case, we have this scenario where we're looking at the region and more is flowing out than is flowing in. Okay, so we say flow out is greater than flow in, and this means that mx is going to be positive. Okay, and so at least that part's positive. We would have to look at ny and pz for sure before we make a judgment overall for the vector field and its divergence. But at least we have an idea. Okay, and so I'm not going to do it for ny and pz, but that's at least the idea. Okay, and so the total growth or expansion is really what we are looking at in the vector field. Okay, just in 3 dimensions. Okay, well, in this case, we could extend this to higher dimensions as well. All right, so in the next videos, we'll get more examples underway and go from there.